Hi, physics friends. Today we're going to be doing a lab that will introduce us to the new topics for this chapter, which is uniform circular motion. So the thing that's uniform in uniform circular motion is the speed. So something to be going around in a circle, and that speed will be uniform. So the kids that are in class are going to be doing a lab using some equipment in class, and I'm going to have you guys use Pivot Interactives to have a similar experience. So their lab is going to require some explanation, and your lab is going to require some explanation. So I thought I'd make a quick video to kind of show you what you're supposed to be doing in this lab, and then I'll come back and answer your questions and whatnot. So if you go to pivotinteractives.com, take a second and get there, you can find a lab that I've assigned to you called the Uniform Circular Motion Lab, and you can see what it looks like below. So the first thing in the lab is there's a little video that shows you the equipment that they use. I'm not sure that you'll watch it, so I'm going to go ahead and play it. You probably will, but I might as well show it to you. So here's the equipment that they're using for the setup. They have jazzy music. I'm not sure if I set this to record the computer sounds. So Einstein has nothing to do with this. He's just adorable. So what you have there is you have a mass, a pulley, a string, and this force, kind of a force sensor. It's a physical one instead of a digital one, but a force sensor of sorts. So what you can change in this is you can change the speed that this platform rotates in, you can change the mass, and then as you do so, the force will respond to that. So the force in this lab is only ever a dependent variable. So as I look below, that's just their setup. You have the video where you're actually going to be taking data. So you can click on this and see what's going on here. But as I scroll down, you see the same setup, and you have some options that you can control. So I'm just going to hit play first. I got to reset mine. So you can see this one's going much slower, just much easier to deal with. But if I pause it here, you can change. Actually, let's look at what you can record. So you can record from here using our tools above. You can record the radius, and I'm not exactly to the maximum radius here, but if I kind of scroll it just a little bit further, I can record the radius that it's spinning in. You can use the stopwatch up here to, if you reset it at the beginning of the video, like that guy, and record one full time around, so you can record the time it takes to go around once. If you know the radius and the time it takes to go around once, you can find the speed that it's going. Since it's going in a circle, the distance that it travels is 2 pi r. So if you do 2 pi r over t, you have the velocity. This gives you the radius in centimeters, but do record it in meters because we're going to relate this to forces. So we want to stay in meters and seconds because we know that that's part of a Newton. If you remember, a Newton is a kilogram times a meter per second squared. So it has those base units in it. So that's the stuff that you can directly measure, and then you can record the force right off of this meter up here. So things that you can change, if I hit the change button, since you can kind of mess around with this one, but we're going to keep the mass the same. I would probably pick a bigger mass to start with because 20 is really small. It doesn't matter which one you choose, but pick one. And you're going to make speed your independent variable. So when you do this, then hold on. Yeah, so I can choose a speed, and then I'm going to keep my radius the same as well. So I'm going to do the same radius, and then I'm going to hit load. Come on, load. Why are you not loading? Oh, it doesn't like my mass. I gotta pick a different mass. We'll do that one. What? There we go. Okay, it's a little finicky. So now that I've got that, I can go ahead and collect data. That one's really small. So on the small radiuses, I don't like that radius at all. Let's use a bigger radius. See if it likes that one. That's a little better. So we're going to stick with that same radius the whole time. Again, it doesn't matter which one you use, but don't use the little tiny one. And we're going to measure the velocity and the force for each one. So after you do one, measure the velocity and the force. You're going to change it and do a different angular speed. So I change the speed and I load again. And again, you're going to measure the velocity and the force. The velocity, remember, you find using 2 pi r over t. The force you'll read from this meter up here. So you're just going to go through and then change the speeds as you go through. Record force and velocity, keeping radius and mass the same. So sorry, I kind of fumbled that trying to get the video to work right, but that's how you do that. So you're going to record all of that on your data table. So you'll set that up below. You're going to make a graph. It shouldn't be linear to start with, so you'll need to linearize it. And the questions you have past that are the exact same questions that the kids in class have on their lab. So when we do a post-lab discussion, we'll all be roughly on the same page, even though their procedures are going to be a little bit different. Actually, I like your lab setup a little bit better than what they have, but I do not have the lab equipment to have a nice flat circle like this. So this is actually pretty cool. So I hope that's enough to get you started. Please work together with your lab group. You guys can be one lab group. Share your data and kind of work on it. I'll mute me, and then I'll come back and check on you guys as you go. Okay. So I hope this helps get you guys started, and we'll work on it.